How's it going, AS Math? It's Mr. Knight here, and we are going to revisit law of sines, law of cosines, and looking at the area of triangles. We are going to be talking about sectors and arc lengths pretty soon here, and we're going to be utilizing the radian measurements that we got from last time with circular measure. But before we do that, it's really important that we review stuff from geometry, which is these type of things with sine and cosine, and then also looking at like an alternative form of solving areas. So before we get into more complex shapes and working with that in trig, we need to definitely review this before I just be like, here you go. All right. So solving for triangles boils down to two things: finding all the missing side lengths and finding all the missing angles. You don't have to do that for these problems. I'm not going to make you solve every length and angle, but that's what solving triangles really boils down to. And we can use these laws to help us out, okay? So let's talk about the law of sines. It's not restricted to right triangles, actually. It works for any triangle. So if we take something that's not a right triangle, we can actually do some trig with it, okay? We're pretty much working exclusively with right triangles the whole time. But let's see where the law of sines really comes from. So what I did was I drew a median down here so that I basically am splitting this triangle into two right triangles right here. So I'm going to work with right triangles to prove the law of sines real quick. Well, we know sine theta is equal to opposite over hypotenuse, okay? And so if I'm looking at the sine of angle A and sine of angle B, I know sine of angle A is going to be this new length of this median h divided by b, opposite over hypotenuse, and so that's what sine A equals. Well, sine B is going to equal opposite over hypotenuse, so it's going to be h over A. And if I rearrange these equations, I can get h. If I multiply both sides by b, I'm going to get h is equal to b times sine A. And likewise, same thing. I multiply both sides by a, I'm going to get h is equal to a sine b. And actually, if I rearrange that a little bit more, if I go ahead and basically what I could do is I could kind of I could divide both sides by a, and then I could divide both sides by b. So if I did that here and here, well, the a's would cancel. And then if I divided b and b from both sides, the b's would cancel here. And pretty much what I'd be left with is sine of b divided by side length b is equal to sine of a divided by side length of a. And actually, if I wanted to extend this further, I'm going to write it like this. It's going to be my law of sines. I'm going to do sine of A divided by side length A is equal to sine B over B equal to sine C over C. And that is my law of sines right there. Definitely write that down. We are going to be working with it right now. Okay? So let's go ahead. Let's put a couple of examples under our belt. We are going to start with this first example right here. Okay, so what we want to do is we actually want to calculate the side length of C. Well, if you look at this, we have angle C and angle B. We also have side length B. So again, if I'm thinking about this, I know sine of B divided by B is equal to sine of C divided by side length C. And let's go ahead and let's replace some of those things that we know. We know sine of B is going to be 35. Divided by b is 7, and that's going to equal sine c, so sine of 105 divided by c. So now, if we want to solve for c, what we could do is, this is a proportion, we can cross multiply. So I'll get c times sine of 35 is equal to 7 times sine of 105. And I'm going to go ahead, I'm going to get c by itself so I can solve for it. I'm going to divide both sides by sine 35, and so all I have to do now is, well, throw this into my calculator. That's what it really comes down to. Once you rearrange it into that, You really want to utilize a calculator because no one knows what sine of 105 degrees is off the top of their head. I don't. If you meet someone, let me know, because I need to bring him in so he can talk to the class. Show us his ways, or her ways, or their ways. Who knows? It might not even be a person. That'd be crazy if it was just like an animal that could talk. It's just like, hey, by the way, I know how to do this really specific move in math. We end up getting 11.78. We'll round it off to 11.8. 11.8 what? I don't care, okay? We're not going to be working with units on these. I just need to know that you can do this. All right, so that is side length C. And does that answer make sense? It does. Pretty much bigger angles correspond with longer side lengths. And that makes sense. As your angles increase, if you look at my tip of my fingertips, the length of my fingertips, that side length, if I made like a line going down, would keep getting bigger and bigger and bigger, right? So that's really what's going on. And that's how you can kind of like verify if you're doing it correctly. Here's another example. This time we are no longer finding a side. We're going to find an angle. Again, same business. We're going to be using that same exact equation, same exact ratios. Well, for this, I want to find sine B. Well, sine B divided by side length B is going to be equal to sine of C. So sine of 63 divided by 5.5. So I really just look for my given information, and that's how I know if it's sine C, sine A, whichever one I'm using. Let's go ahead. Let's rearrange this. Sine B is going to equal, if I multiply both sides by 4.7, I get sine B is equal to sine of 63 times 4.7 divided by 5.5. So let's see what we end up getting. Sine of 63 times 4.7 divided by 5.5. Make sure you are in degrees. And I get like 0.76. Go ahead and do 1. And of course, I'm looking for the angle B. So to do that, I need to take the arc sine of both sides. Again, I will put that in my calculator. I'll make sure that I am in degrees when I do this. So B is equal to the arc sine of that. And we end up getting, hey, 49.5 degrees. Again, that angle should be smaller than C, and it ends up being smaller than C because the side length is smaller than C. Well, let's move on. That's the law of sines. That's really all it comes down to. If you have two sides and an angle, you can work with law of sines, or vice versa with if you have two sides or two angles in a side, you can also work with it, just like we saw with example 1. Okay? Well, let's look at law of cosines now. Now, unfortunately, I'm not actually going to verify or prove the law of cosines like I did the law of sines, because it's not really that important. It's not super useful. I guess the law of sines showing it isn't the most useful thing either, but just have some faith in it. I care more about what law of cosines is and what it's useful for. And these are its two instances. So it's great for finding like a third side if we know two sides and the angle between them. And you're going to see an example of that pretty soon here. And also the second one, if I know all three side lengths, I can find all the angles using the law of cosines. That's what I want to do. So basically, here's the law of cosines right here. If I'm given some kind of triangle like this, I can utilize the law of cosines. C squared, so side length C squared, is equal to A squared plus B squared minus 2AB times cosine of C. Now, I put a little like red mark underneath it because unlike law of sines, it can be a little confusing with law of cosines. Here's an alternative form of it as well. We're going to see why this guy is more useful in a little bit, but this is an alternative form. They are the same equation. This one is just rearranged to solve for cosine C. And once again, I underlined the C. So why am I doing that? Well, the C is indicating that these equations are really just specific to C. We're not always solving for side length C or the angle C. Sometimes you want to do that for A and B. So for example, if I do it with B, I just have to swap this where the C was for B. That's really what I got to do. Now, as a result, that means that these guys, the AB, will also switch, right? So now I've switched C with B, and now I switch my B with C. Everywhere I go, I'm going to have to substitute in my C with B. Right? That's pretty much what's going on. So pay attention to that. Pay attention to that when you're swapping these out, okay? Let's go ahead. Let's work a couple examples with this. Here's our first example. So again, kind of what it was talking about before, like great for using or when to use it, is the third side is what we want to find when we know two sides and the angle between, just like this. That's a great time we want to use the law of cosines. So we know the law of cosines, and we're trying to find the length of C, so we don't have to change anything up. But so this will be C squared is equal to A squared plus B squared minus. So it's basically Pythagorean's theorem, and then I do the minus 2AB cosine of whatever, right? 2AB, what I just used, and then cosine of whatever I'm trying to find, that associated angle. That's probably the most confusing part about this, so be mindful of that. And now let's just start plugging in some values. Again, we obviously don't know C squared, but we know A squared is 8 squared. We know B squared is 11 squared, and that's pretty much all we're going to need. And of course the angle cosine of C, which was 37 degrees. All right, that's a lot to put in the calculator, okay? And on top of that, we're going to have to square root at the end. So we need to really pay attention to what we're doing. Now, when I do this, I don't try to throw it in all at once. You can. There's a good chance you can, and you'll be fine if you're comfortable with it. But I would focus on this part first, and then add this stuff after. So let's see what that looks like. I'm going to do cosine of 37 times negative 2 times 8 times 11, and boom, I get this entire thing right off the bat. Well, then I know I got to add 11 squared, and I also have to add 8 squared. So I can add those real quick. Get that? And now I need to take the square root, because this is still C squared is equal to that. So C is going to equal the square root of this, and I get about 6.67 for my length. Again, I don't care about centimeters, meters, anything like that. Okay? And yeah, then that's pretty much it. We could go ahead, we could use law of sines as well, or we could continue using law of cosines. We could try to find A and B's angles, but we don't have to do that right now. Okay? So 6.67, nicely done. Let's move on. Now, sometimes, this is the other instance of when law of cosines is good. Sometimes we have all the side lengths revealed, but none of the angles. Okay? This is when we actually want to use the alternative form of this. Okay, we're finding angle C. Let me write it down. That's cosine C is going to be equal to A squared plus B squared minus whatever this guy is, the associated side length, divided by 2AB. All right? So again, it's just kind of swapping out, you know, if it was B, then this would be cosine of B equals A squared plus C squared minus B squared over 2AC. That's if we are finding angle B, but we are not. Okay? So let's plug some stuff in. Cosine C is equal to A squared is 9 plus B squared is 5 squared minus, and make sure you're associating the opposites. Right? So if I'm talking about side length C, I know this is side length C because it's right across from the angle C. I know this is side length B, I know this is side length A, so on and so forth. Okay? Just when I'm doing that. Maybe it helps to label it too. Okay? That's supposed to be a 9. Alright, cosine of C. Let's see what we can get. Again, I would probably just focus on the top part, click enter, and then save that answer. So 9 squared plus 5 squared minus 8 squared. And that's going to be divided by, I'm going to put it all in one quantity. 2 times 9 times 5. Alright? And then I have to take, the arc cosine of that. So I take the arc cosine of that answer, and I end up getting 62.2 degrees. There we go. We are done. On your homework, though, it might not say find angle C. It might say find angle C like that, or like find the measure of angle C, something like that, okay? It also might not say find side length C. It might say find length of AB. It'll actually like give it like a segment. But either way, you should be fine, okay? And then finally, let's look at area with sine. This one I will show you because it's kind of weird, and I think it needs a little bit more explaining. So, given another triangle, and any kind of triangle, I'm going to work an area with sine. So I'm going to drop this down, and once again, I'm going to call this h right here, okay? So basically, base times height divided by 2 is going to give me the area of this triangle. Right. But let's say now using sine, I can kind of work with that. So again, I know sine of A can be written as opposite over hypotenuse, so h over c. And I also know that we'll go with sine of c. I know sine of, or I guess we'll just leave it with sine A. We'll keep it with sine A. Well, that means I could actually rearrange this guy and solve for this height right here. That means I'm going to get, after I multiply both sides by c, I end up getting sine A times c is equal to h. Well, that h is right here. So I can actually replace that. I can replace that h with this guy right here. C sine of A. And actually, that's the area of a triangle. Okay, that's an alternative way to write it. Now, there are many other ways to write this, kind of like the law of cosines. Let's say, for example, I wanted to find, let's say I had side lengths A and B instead. Side lengths A, B, and then it would be sine C. So whichever like side length I'm not using, and then of course this could be written as 1/2 AC sine B. Either way, you're pretty much using the same general form of it. Again, you just got to be mindful. You got to be mindful of if you have these side lengths, then you're getting the angle of the side length you don't have. Okay, and so you can write down all 3 of these. I'm totally fine with it. Either way, we're going to be working with it because here I'm not even going to give you A, B, and C. I'm just going to say here's this triangle. Find the area. Well, I'm going to just plug it in to this equation right here. I know it's 1/2 times, I have my 2 side lengths, 3 times 4, times sine of whatever that angle is between them. Okay? And now I throw that all into a calculator, and you know, I'm pretty much done with the problem at this point, right? So it's 6 times sine of 145, and I get 3.44. You can actually put units squared for this one because we are talking about an area, right? And that's it. So your homework is just going to be about working with those 2 laws as well as this alternative area formula, and just like normal, and to get us prepared for when we tackle sectors. This is Mr. Knight signing off. Have a great one, guys.